Hey guys, welcome back. We are signing in here for video 7. We're going to talk about parent functions and transformations. Okay, so parent functions basically are going to be what do we start with a function, and then transformations is how are we going to move that initial parent function. Okay, so we're going to talk about four main types here. We have a constant function. Okay, constant function is just f of x or y equals some number. Okay, a is any number. Your domain is always going to be all real numbers because your x values are never going to stop going left and right. Your range is going to consist of one single number. Your range is just whatever this number is here. Okay, so I could say like a here. All right, and here's an example of your graph. So this is like y equals 1. All right, and we've got a straight horizontal line through y equals 1. That's a constant function. Y is always 1. Your domain is all real numbers. Y is always 1 for your range. Okay, your next one is your identity function. So this is what we typically think of as a linear pattern. Okay. So we've got f of x equals x, so your slope in this case would be 1, and then we would be like adding 0. So that's your initial function, okay? And we can always change the 1 and we can change the 0, okay? F of x equals x passes through all points with coordinates a, comma a, meaning if x is 1, y is 1. If y is 2, that means x is 2. Or sorry, if x is 2, y is 2, meaning your x and y coordinates match. Your domain and range is always going to be all real numbers for these type of functions, okay? Because here's my example of y equals x here. My line is never going to stop going left and right, and it's never going to stop going up and down, so your domain and range are both all real numbers. Okay, then we have absolute value functions. Absolute value functions are f of x equals the absolute value of x. They are V-shaped. Your domain is always going to be all real numbers because it will go forever to the left and forever to the right. Your range depends if the graph moves up and down, and we'll talk about that in a little bit. In this case, this is your original parent function, y equals the absolute value of x. And in this case, it didn't move up or down at all, so we start at 0 here, and it's everything above 0 for your range. So your y values go up, so y is greater than or equal to 0. So if your v started down here, it would be y is greater than or equal to -4. All right, and then we have quadratic functions. Quadratic functions are very, very similar to absolute values, what you're going to end up finding out. We've got x squared, y equals x squared. They're U-shaped instead of V-shaped. Your domain is also all real numbers for these guys. And then your range also depends on if it moves up and down. In this case, this one that I graphed here, this is your parent function. We start at 0. Your domain is all real numbers, that will never change, but your range is y is greater than or equal to 0 because it's above 0. If your vertex started there and your graph were to go up, it would be y is greater than or equal to 3 for your range. Okay, so it just depends on whether your graph moves up or down or not. All right, so what we're going to do for these next examples is we're just going to tell what the parent function is, okay? So we've got y equals, or f of x or y equals x squared minus 4. We have a squared here, so this is a quadratic. Here we've got absolute value symbols, so this is absolute value. These are obviously not the parent function, but this is the new function based on how the parent function moved. So these functions are going to move just in a little bit different direction, but this is still going to be a U shape. This is going to be a V shape. Okay, this is just y equals a number, so this is constant, which tells us that it's going to be a flat line somewhere. All right, we've got y equals 2x minus 1. This is linear, or in other words, this would be our second one that we talked about, which is an identity. If you say linear, I'd be fine with that as well. Okay, f of x equals -4x. This is identity as well, or linear, however you want to say it. F of x equals absolute value of x plus 4. This is absolute value. And we've got some graphs here. Okay, so we've got this one, it's a U shape, so this is quadratic. This one is just a straight horizontal line, so this is constant. Here's our V shape, so this is absolute value. And then this one is a diagonal line, so it's not constant, but it is an identity, or it's linear. Okay, so at this point you might want to take some time to pause the video and actually get all those graphs written down, because there's some nice examples for you to look back at. All right, now we're going to start actually transforming these graphs. So we talked about the parent functions. Now we're going to start transforming them or moving them around. Okay, so the identity function, okay, so your y equals x, it can, if we add a value or subtract a value, it moves it up or down. So if we add something here, so our y-intercept moves it up or down. Okay, the slope makes it less steep or more steep. So if it's a positive, and if it's a positive slope, it looks like this. A negative slope looks like this. So for example, we've got this example here, y equals negative 2x minus 4. This is going to move it down because it's minus 4. It's going to be steeper because this number is greater than 1. And it's going to be a negative shape. Okay, so in other words, here's our normal graph. This would be y equals x. Since that's more steep and it's going negative, it might look something like this. Oh, and it went down 4, so it's actually going to be more like right there. Okay. All right, this next one is going to move up 3 because of this plus 3. It's going to be less steep because it's a slope of 1/2, and so it's less than 1. And then it's going to be a positive shape, so it's going to go like this. All right, next we have our absolute value. So there's quite a few rules with absolute value that we're going to have to remember here. So when we have absolute value, we can add a value inside here. Okay, if we add a value, that moves it left. If we subtract a value here, it's going to move it right. All right, so basically what I mean by that is we're going to take this V and we're going to either shift it left or right. So our V might be like right here, or it might be over here if we add or subtract a value. All right, adding a value on the outside, so out here, outside the absolute value, moves it up and down. Subtracting it moves it down, adding it moves it up. A negative number in front flips the graph. So it turns, so if I had a negative number right here, it would go upside down. And then finally, a number greater than 1 makes your V skinnier. So if this number out here is bigger than 1, it makes it skinnier. If it's a decimal or a fraction, it makes it wider. All right, our quadratics work the exact same way. Okay, so we can think of y equals x squared as y equals an x in parentheses, and then we can add and subtract stuff inside the parentheses, which is going to move it left and right, and we can add stuff over here, which is going to move it up and down. Okay, so let's look at a few examples here. So we're going to tell what the parent function is and then what direction it moves. Okay, so this is absolute value because we have absolute value signs. Okay, this plus 3 in the middle is, since it's in the middle, our absolute value rules. If we look back here, anything, if we're adding a value inside, it moves it left. So that's what's happening here. So we're going to go, so this would go left 3. And then our other rule is that if we're subtracting a value on the outside, it moves it down. So it would also go down 2. So basically, if I want to visualize that, you don't need to do this part, but if we want to visualize that part, my V would be down 2 and left 3. So my new vertex would be there, and my V would look something like that instead of starting at the origin. All right, number 2 is a quadratic because we see a squared there. All right, this plus 4 in the middle is going to move it left 4. The plus 5 on the outside is going to move it up 5. And then the 2 in the front, okay, works just like if we had a number in front of the absolute value. So a number greater than 1 makes the V skinnier. Okay, well this is greater than 1. Okay, so in this case it's going to make the U skinnier. So if I had to imagine my graph, my u is going to go left 4 and up 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. That's where my new vertex is. And it's going to be skinnier. So instead of being a nice wide u, it's going to look something like this maybe. All right, number 3 is linear. And it's going to move down 4. And my slope is -3, which means it's going to be a negative shape. So it's going to be like this. And it's also going to be less, it's going to be more steep, because this is greater than 1. All right, and then my last one here is an absolute value. The -2 is going to move it right 2. It's not going to move up or down at all. But the 1/2 is going to flip it because it's negative, and it's also going to make it wider because it's a fraction. All right, and that is transformations and parent functions. We will see you guys next time.